G'day comrade subscribers. Yes, finally a little bit more work on the Vektor 06C.02. So the issue with this one is the sync, I believe. So I'm going to take some measurements on the oscilloscope, and we'll have a look at the schematic and compare it, because there is a modification done that I'm hoping will fix it. So we'll have a look at that, and I've created a little PCB for it because I'm not very good at doing doing hand bodges with transistors and stuff. So, but we'll have a look at that. So let's have a look at what we've got at the moment, and then let's see. All right, so we'll have a look at the this is the composite sync. So this is the horizontal and the vertical sync after it's been combined. 1 volt per division. So I think, yeah, this is the composite sync. Whether or not that's correct, I don't really know off the top of my head. All right. Now, if we look at the separate horizontal and vertical syncs, so we'll have a look at the SSI, the horizontal sync, although Roman said in the last video that that's actually more like the line sync, what they refer to as the line sync. So in theory, it's supposed to encompass the shorter sync, but in the basic scheme, simplified. So old Soviet TV sets are pretty okay with this, but some modern digital converters aren't working with it. So SSI, so that's D89, pin 5 for the positive going one. 1, 2, 3, 4, 5. Let's just adjust that. Period 64 microseconds, frequency 15.61. So if we go to measure, what was that, all measurement? No, okay. So just, I think that's the negative going width, 10.68 microseconds. Oh, there we go there. So what's that, period 64 microseconds, frequency 15.63, positive width 53, negative width 10.11 microseconds, which is close to what Roman said, I think. Now that's the positive going, so if we look at the inverse, pin 6, surprise, surprise, it's inverted. So that's the inverse one. And then if we have a look at KSI, which is the vertical sync, so pin 9 is the positive going 1, 8, 9. Is that there basically? And then the negative going 1, pin 8. So that's the vertical sync. So I don't think the vertical sync's an issue, it's the composite slash horizontal sync. Anyway, so that's how it is at the moment. Let's power that off. Let's have a look at the schematics. I've kind of redrawn the schematics. Have a quick look at what I've got here. So this is from my notes. It's not so much composite sync, but composite. From the schematic. So as I was saying, we had horizontal sync, and then we've got the inverse there, and then we've got vertical sync, and then the inverse there, and then we've got RGB. Also, we've got the composite video signal here. Anyway, so I've redrawn it in KiCad and then come up with a little PCB design. that hopefully will fix the problem. Let's have a look. So here's the schematic I redrew of the video output section, well, as far as I can understand it. So we've got basically horizontal sync coming down here. We've got vertical sync here. Sorry. And then it gets combined, so we've got composite sync there. And we've got horizontal sync here, which is then combined with the RGB elements, which come out of these little RAM things here. We also have RGB plus Luma, I think, generating the composite video here, and then I guess buffer, and then so we've got video slash sync. So if you're using the RGB, you can use this for composite sync. Zabook, so sound, and I think that's like SCART control sort of thing. So that's how it is at the moment. RGB. So yeah, we've got some sort of issue with the sync causing not really working well. So that's it at the moment. So if we have a look, I think at the modified version, so the modifications that they've done is they've removed this, and now we're taking the inverted horizontal sync through here and then combining it with the RGB elements. But for the RGB, we've now got these new transistors here, so I guess emitter followers, so basically buffers, so better current drive, I think. We've disconnected the composite video here, so that's no longer coming into this sync here, composite sync, and we've added this variable trim pot, the variable resistor of some unknown value. I've gone for 10 kilo ohms, maybe it's 1 kilo ohm, I don't know what it is. So that's the difference. So we've removed this. This is gone. This is gone. We've added this in. We've added these in. We've added this in, and we've deleted that basically. So as a result, I've come up with this mod. This basically takes the changes. So we've got the three RGB emitter followers here. So the buffers. So blue in, blue out, and we've got blue in, blue out over there. And then we've got this one here, actually using the collector. So we've got inverted horizontal sync coming in, the emitter's connected to ground, then we've got this trim pot which I've specified as 10 kilo ohm, and then we've got the horizontal sync out, and so then I've got over here another plus 5 volts ground, and then sync in, well the horizontal sync in basically, and then the out. So the result is this PCB here. If we have a look on 3D, basically this here. So rather than me making a mess of the rather beautiful board, vector board, I've just made this little daughter board here. So and then we're just going to have some fly wires, so bringing the RGB signal in, and then we've got RGB going out to the DIN socket. So obviously we're going to have to cut a couple of traces, but that'll be minor. And then we've got I think BT3 here for the sync modification as well. So sync in, sync out. So hopefully I can just stick this little board in, and magically we will get some decent video out of this quite interesting machine. Actually, it's quite interesting. One of the most interesting machines, I think, that I've had a look at. It's just unfortunately the sync is causing me problems. So if I can get this sorted, we might be good. So that's where we're at. Just a quick update. So I've ordered this today for PCBWay, so probably about 2 weeks time, so middle of October. Hopefully we'll make some progress. That's it for now. Thanks for sticking around, and talk to you later. Bye.